So hey guys, a very good day to you all, and today we will be starting the new chapter, that is the periodic table. And guys, on our channel you will be finding all the video lectures related to the chapter periodic table. You can find the link in the description box below, or you can simply click on this link and access all the videos related to the chapter periodic table. So since it is the first lecture, let us understand what topics that we are going to cover in this particular video. First of all, we will understand the introduction of the chapter periodic table. After quick introduction, we will move on to the unitary theory. After unitary theory, we will understand the Dobereiner's triads, and after that we will move on to the Cooke's homologous series. Then we will understand Newland's Law of Octaves, and at the end we will understand the Mendeleev's periodic law and its significance. So guys, you make sure you watch this video till the end so that you get to learn all these topics in the simplest way possible. So without wasting much time, let's start with the first topic, that is the introduction for the today's lecture. Okay, so what happened in the year 1800 was that only 31 elements were known. So since less number of elements were known, it was easier for the chemist to remember them as well as to remember their atomic numbers and atomic mass numbers. But further on, in the year 1885, there were 63 elements known. Now guys, the number of elements has increased, and since the number of elements has increased, now it is difficult for the chemist to remember them all and to remember their atomic number as well as the atomic mass number and different chemical properties. So the chemist began to realize that there is a need to arrange these elements in proper way. Now understand guys what I'm trying to tell. See, suppose you go to the library, and in the library, let's assume that all the books of all standards from standard 1 to standard 12 are mixed. Okay, so all books are kept mixed, and you go to the librarian and ask him for a chemistry book of class 11. Now just assume guys how much difficult it is going to be for the librarian to remove that particular book in a bunch of so many mixed books. So for that, what librarian does is that he arranges the books separately according to the standard and according to the subjects, so that whenever he wants to access a particular specific book, it is easier for him or her to access that book. Suppose you go to the librarian and ask him for a chemistry book of class 11. So what he will do, he will first move to the section where class 11 books are kept. Then he will search for the chemistry book. So now it is easier for the librarian to access the book. Similarly, when it comes to elements, we need to arrange the elements so that we can easily remember their atomic number as well as their atomic mass numbers. So the elements and their compounds showed a great variation in chemical behavior, and it is very difficult for us to remember them in a haphazard manner. Okay, so there is a need to arrange them in a particular specific manner. Several efforts were made to classify the known elements in a systematic way. Many scientists tried to arrange them in a particular systematic way. In this video, we will be understanding the 5 systematic ways proposed by 5 different scientists. Okay, now before starting with them one by one, let me tell you all that as of now, there are 118 elements known. I am making this video in 2020. So as of 2020, there are 118 elements known, and there is a high possibility that more elements will be known after in the future. So let us start with the first systematic way, that is nothing but the unitary theory. Now what does the unitary theory tells us? In 1815, it was William Prout who suggested that atomic mass of all elements is a whole number. Now what is the meaning of this? What is the atomic mass of carbon? It is 12. And as we all know that 12 is a whole number. What is the atomic mass of calcium? It is nothing but 40. And as we all know that 40 is nothing but a whole number. So what William Prout said was that all the elements have atomic mass number which is nothing but a whole number. And as we all know that the atomic mass number of hydrogen is 1. So he said that so hydrogen can be considered the basis of all atomic mass. Now what is the meaning of this? He said that C12. Now what is this C12? A carbon atom whose atomic mass is 12 is made up of 12 units of hydrogen. Now why did he say so? See, now understand this. What is the atomic mass of hydrogen? It is nothing but 1. Atomic mass of hydrogen is 1. And what is the atomic mass of carbon? Atomic mass of carbon is nothing but 12. So he said that when we have 12 hydrogen atoms together, we will get 1 carbon atom. This was proposed to us by William Prout. Similarly, he said that for calcium, whose atomic mass number is 40, is made up of 40 units of hydrogen. But this was just useless. This theory was ruled out. Now why it was ruled out? Because it was found that copper has atomic mass 63.5 and chlorine has atomic mass 35.5. And as we all know that 63.5 and 35.5 are nothing but decimal numbers and they are not whole numbers. So since unitary theory was rejected, now comes Dobereiner's triad. This is a very beautiful concept. I really like this concept and I really appreciate Dobereiner for this. See, what he said was that in 1817, a German chemist Dobereiner said that the elements could be arranged in the group of 3, which means that he said that we can arrange the elements in group of 3, 3, 3 like this. We can make group of 3 elements. He named these groups as Dobereiner's triad, which means that a group of 3 elements, he named them as Dobereiner's triad. He just gave his name, that is Dobereiner's triad. But the question here is that how to decide which three elements we must take in one group. Is there any specific rule that we must have only those specific 3 elements in one group, or we can take any random 3 elements in one group? Now to answer this question, he gave us an example. He said that let us consider a group of lithium, sodium and potassium atom. As we all know that the atomic mass of lithium is 7, atomic mass of sodium is 23 and atomic mass of potassium is nothing but 39. And he said that the atomic mass of middle element is almost equal to the average of atomic mass of other 2 elements. Now in simple words, if I tell you all, the atomic mass of middle element, which is the middle element over here, it is nothing but sodium. So he said that the atomic mass of sodium is nothing but almost equal to the average of atomic mass of lithium and potassium. I repeat myself again. He said that the atomic mass of sodium is almost equal to the average of atomic mass of lithium and potassium. Now even if you have not understood up till now what I am trying to say, you will understand it better when we do it mathematically. Okay, so how we can find out the average of atomic mass of lithium and potassium? Simply by adding the atomic mass of lithium and with the atomic mass of potassium. So when we add atomic mass of lithium and atomic mass of potassium and we are going to divide it by 2, we get the average. I hope you all know this basic math, guys. Average. Since we are adding mass of two atoms over here, that is of lithium and potassium, therefore we are dividing by 2. So when we add their atomic mass and divide by 2, we get the average mass. Now the average mass comes out to be 7 plus 39 divided by 2, which is nothing but 23. Now the average of atomic mass of lithium and potassium has come out to be 23, and this 23, guys, is nothing but the atomic mass of sodium. Now read this statement again. The atomic mass of the middle element is equal to almost equal to the average of atomic mass of other two elements, that is nothing but lithium and potassium. I hope you all got to know what I'm trying to say. And this was not the only example that he gave another example. He said, let us consider a group of chlorine, bromine and iodine, where the atomic mass of chlorine is nothing but 35.5, atomic mass of bromine is nothing but 80, and atomic mass of iodine is nothing but 127. So now what we are going to do, we are going to first of all find the average of atomic mass of chlorine and iodine. So we find out the average, that is 35.5 plus 127 divided by 2, which gives us 81.25, and this, guys, 81.25 is almost similar to 80. He never mentioned that it will be equal. See, what does the law say? Almost equal, almost. He never said that they will be exactly equal. So this was the concept that Dobereiner put forth, and he gave us another example of calcium, strontium and barium. Atomic mass of calcium is 40, strontium is 88 and barium is 137. So we find out the average mass of calcium and barium as 40 plus 137, and we get something as 88.5, which is almost equal to strontium. Now guys, I purposely emphasized on these Dobereiner triads because this Dobereiner triads is the only possible topic when it comes to the methods of periodic distribution. In your competitive examinations like your JEE Main and CET, it is a possibility that a question might be asked from the Dobereiner triads. Dobereiner triads is a favorite topic for your competitive examinations. So make sure you go through this thoroughly. Okay, now moving ahead, everything was fine. He was able to make a group of 3, but this seemed to work only for few elements, and hence it was also rejected after many elements were discovered afterwards. So this group of 3, that is the Dobereiner triads, worked only for very few elements. He was not able to make group of 3 for all the elements, therefore he was rejected. Now comes Cooke's homologous series. Now this is something a weird series or something unique method. Let's understand it. In 1854, J.P. Cooke classified the elements in several homologous series, which means that he created a homologous series of different elements according to him. He created according to him, and he created on the basis of their physical and chemical properties. And he said that, actually discovered that the atomic mass of the elements present in a homologous series increase in regular fashion. I know that you have not understood anything from this statement, but I make sure you will understand when you look at this table over here. See, he made a group of nitrogen, phosphorus, arsenic, antimony and bismuth. As we all know that the atomic weight of nitrogen is nothing but 14. So he said that let's assume 14 to be A. Okay, so he assumed 14 to be A, and as we all know that the atomic weight of phosphorus is nothing but 31. Now can I write this 31 as 14 plus 17? And we have already assumed this 14 to be A. So can I write this to be A plus, and now he assumes 17 to be B. So A plus B. And now comes arsenic. What is the atomic weight of arsenic? It is nothing but 75. And can we write this 75 as 14 plus 17 plus 44? Now he has already assumed 14 to be A. As it is, I am going to write A over here. He has assumed 17 to be B. So we write B over here. So A plus B. And he assumes 44 to be C. Now he moves on to antimony. What is the atomic weight of antimony? It is nothing but 119. Now can we write this 119 as 14 plus 17 plus 88? Now this 14 is nothing but A, this 17 is nothing but B, and this 88 is nothing but 2 times 44. And we have assumed 44 to be C, so can I say it is nothing but 2 times C. And last, the bismuth, whose atomic weight is 207. Now can we write this 207 as 14 plus 17 plus 176? And he assumes this 14 to be A, this 17 to be B, and can this 176 is nothing but 4 times of 44, and 4 times of 44 means nothing but 4 times of C. Now these equations are very weird to remember. Here he has discovered only, he has 5 elements, he has made a group of 5 elements, and for that we have to remember the 5 equations. Although he was not able to justify these equations for all the elements, therefore obviously he was rejected. Now comes Newlands Law of Octaves, another beautiful law. In 1865, an English chemist named John A.R. Newland found out that the elements known at that time, means whichever elements were known at that time, were arranged in increasing order of their atomic weights. So what, now you have understood what till now, that whichever elements were known at that time were arranged in increasing order of their atomic weights. The properties of every 8 element were similar to those of the first one. Now what is the meaning of this? See, first of all, what he did was that whatever elements were known at that time, he arranged all of them in increasing order of their atomic weights. And when he when he arranged them in increasing order of their atomic weights, what he discovered was that the property of the first element, property of every first element and every 8th element was same. I know many of you have not understood anything. Let's move on to the table which will help us to understand. See, this was the table which was put forth by Newland. And what he said was that the first element, let us assume that lithium is the first element. Now we count up to 8. First, second, third, fourth, fifth, sixth, seventh, and 8th. So the first element is lithium and the 8th element is sodium. Now what he says is that lithium and sodium, they both will have same properties, that is similar properties. Similarly, if you assume beryllium to be 1, now count up to 8, that is 1, 2, 3, 4, 5, 6, 7 and 8. So what he said is that the first element beryllium and magnesium is going to have similar properties. He placed them one below the other. So now can I say that boron and aluminium is going to have the same properties, the carbon and silicon is going to have the same property, the nitrogen and phosphorus, they both are going to have the same properties, similar properties guys, and oxygen and sulfur is going to have the similar properties, fluorine and chlorine is going to have similar properties, and here can I say that sodium and potassium are going to have the same properties, whereas magnesium and calcium is going to have the same properties. Now what I want you all to observe over here, see, lithium and sodium are having same properties, and sodium and potassium is having same properties. Now since all three are having same properties, so can I say that lithium will be having same property like the potassium? Similarly, beryllium, magnesium and calcium, they all have similar properties. So now can I say, guys, that all the elements in the vertical columns are going to have the similar properties? So all the elements which are in the vertical columns are going to have the similar properties. Okay, so now everything was fine for Newland, but here comes a problem now. Newland was able to arrange these elements in the system where the first element is having the similar properties like the eighth element only up to calcium. His law worked only up to calcium. It did not work for atomic weights ahead of calcium. So it was not applicable for elements ahead of calcium. Hence, it is obvious that Newland's law has to be rejected. And the main reason for the Newland's law of octaves to get rejected is because of the discovery of inert gases. The inert gases had drastically different properties from these elements which are known, and as a result the Newland's law of octaves got disturbed and he was not able to arrange the further on elements. So but this law was rejected. As we have seen, the inert gas were found to be quite different from other elements, and this had a great impact on the Newlands law of octaves. Now, okay, so now here comes Mendeleev with his periodic law and its significance. Let's understand them. So Mendeleev was the first one who have a great impact on the systematic arrangement of elements. Mendeleev's work was really appreciable. What he did was that Dmitry Mendeleev in 1869 proposed the Mendeleev's periodic law. And what does this law state? Let's understand that. The physical and chemical properties of element are periodic function of their atomic weight. Now what is the meaning of this statement? He said that the physical and chemical properties of elements are going to repeat themselves periodically as the atomic weight increases. I repeat myself again. The physical and chemical properties of elements are going to repeat themselves periodically as the atomic weight increases, which means that after a certain period the same physical and chemical properties will be repeated. So he arranged the elements in horizontal rows and vertical columns similar to the Newland's law of octaves, and as we all know that he arranged them in the increasing order of atomic mass. Now let's understand his periodic table. This is the periodic table which was put forth by Mendeleev, and he said that the elements in the vertical columns, the elements in the same vertical columns are going to have similar properties. For example, the elements in the first column, all of them are going to have similar properties. The elements in the second column, all of them are going to have similar properties. And he also left some places. Can you see there are some places left over here? He said that these places are left for the elements which are not yet discovered but will be discovered in the future. So whenever these elements will be discovered in future, we will add them in these blank spaces. Now there is one weird thing over here. Can you observe here? Ekka aluminium and Ekka silicon. Aluminium and Ekka silicon are nothing but the places left for gallium and germanium, and he also predicted the properties of gallium and germanium. And when gallium and germanium were discovered and placed in this table, it was found out that the properties predicted by Mendeleev were exactly same. So this Eka aluminum and Eka silicon were nothing but the places for gallium and germanium. And Mendeleev had already predicted their properties, and these properties almost proved to be right. Okay, there might be some little bit of difference, but it was almost proved to be right. Okay, now you might have observed, if you are a good observer over here, can you observe that the atomic mass of cobalt is 58.9 and the atomic mass of nickel is 58.7. Nickel has less mass than cobalt, then also it has been placed after cobalt. Why is it so? Because he found out that cobalt had similar properties to rhodium and your IR. So he found out that cobalt had the similar properties to rhodium and IR, therefore he placed cobalt in this column, whereas nickel had similar properties to palladium and platinum, therefore he placed nickel in this column. But actually this is wrong, na guys. Nickel has less mass, then how can it be placed after cobalt? And he said that the atomic mass of nickel and cobalt might be wrong, but they are having similar properties. As the rule says, the column must have similar properties, therefore I am placing them in similar columns. Okay, now similar, beryllium is having atomic number 128 and your iodine is having atomic. Similarly guys, your beryllium is having atomic mass number 128 and your iodine is having atomic mass number 127. So it is obvious that beryllium has greater mass number. So beryllium should be placed after iodine, but iodine is placed after beryllium only because of the fact that it is having similar properties to the column which has fluorine, chlorine and manganese and bromine. So only because of the similarities in the column, similarities in the properties of the columns, he had to place them irrespective of their atomic weights. So this is the mistake in the Mendeleev's periodic law, but he surely had a great impact. So this law was also rejected. So guys, do check out my channel where I have uploaded chemistry and physics videos. They might be helpful for y'all, and don't forget to subscribe to my channel for more such interesting videos. And thank you for watching this video.